that is bigger, bolder, and even more exciting. As a part of our workshop series, we continue exploring some of the most practical and in-demand areas in cloud computing and software development. And today's session is definitely one you don't want to miss. Today, we dive into session number 2, from IDE to production with Google Cloud. A session focused on how ideas move beyond development environments and become real, scalable solutions in production. And to guide us through this journey, we have an incredible speaker lined with us today. It is now my pleasure to introduce our speaker for this session, Mr. Suresh Peiris. Mr. Suresh is the founder of Articom Incorporated and a specialist in CX agentic AI platforms and AI transformation. He also serves as the GDG Sri Lanka lead and is actively involved in academia as a lecturer and researcher at IIT Sri Lanka. With a strong passion for innovation and product development, he focuses on building impactful, user-centered solutions that combine technology, business strategy, and real-world problem solving. His journey reflects a powerful blend of technical expertise, leadership, and innovation, with experience spanning cloud technologies, enterprise applications, AI-driven solutions, and digital transformation. Beyond his technical expertise, he is also skilled in business development, project management, and strategic growth, supported by excellent communication and interpersonal skills that help bridge the gap between technology and business needs. With his hands-on experience in cloud and product development, he is perfectly positioned to guide us through today's topic and share valuable insights on taking applications from development to production using Google Cloud. We are truly delighted to have him with us today. Ladies and gentlemen, please join me in welcoming Mr. Suresh Peiris. Sir, the floor is yours.
Good evening, all of you. First of all, before I begin session, can I get a small confirmation on whether I'm audible to all of you?
Yes, sir, you're audible.
All right. Okay, thank you. So let me share my slides. I guess my slides are visible as well. Can I get a quick confirmation?
Yes, your slides are also visible, sir.
All right, perfect. So, hi everyone. I'm Suresh Peiris. Like in the introduction, I'm one of the co-founders of Articom Incorporation. It's an AI agentic platform. As well as I'm a GDG Sri Lanka lead, which is known as the Google Developers Community. And as well as I'm a lecturer at IIT as well, heavily involved in AI and cloud research segments. So yeah, that's a very brief about myself. So let's dive into the session and let's see what we have in the lineup for the day. Anyways, let me ask a simple question before I start the session. So can I know how many of you are very beginners into cloud computing? So in that way, I can align my session based on the different audiences we have. Can I see a raise of hands, those who are very freshers and beginners to cloud computing? All right, we have a couple of people raising hands. All right, can I know how many of you have already worked on any sort of cloud application development, some sort of intermediate level experience? Those are intermediates on cloud computing. All right. So I guess the majority is beginners. So anyway, that's all right. So I'll try to make the session more diverse session focused on multiple user groups, including beginners and intermediates, as well as the people who has some sort of background in terms of cloud computing. Also, I have a giveaway at the end of the session as well. Those who are staying till the end of the session will be getting over 2000 USD of free credits to access Google Cloud Platform, especially the people who wants to start their own startup as well as those who are going in the product line. I have a small offering, 2000 USD of free credits with y'all. I'll provide the link at the end of the slide deck so y'all can apply and I can get the support from Google Southeast Asian team. All right, so let's dive into the session. So first of all, this is for the beginners actually. So let's understand what is cloud before we go into the theoretical parts and before we dive into the technical concepts. Let's understand what's cloud computing. So cloud computing is all about hosting your resources, hosting your web resources and backends and front ends and any sort of computerized resources on a virtual server, right? For an example, we could say that a cloud computing concept can be known as you are using someone else's computer to deploy your work, right? So I guess um, can someone please mute the microphone, please? Maybe the security settings can. Yeah. All right. Okay. So I appreciate if you all can keep the mic on mute during the session so we can continue it without any sort of interruptions. That's all right. Okay. So let's understand what's cloud computing. So I believe all of you have seen this picture, right? I maybe when the beginners, maybe some of you all might have visited this sort of place. This is known as a data center, right? In Sri Lanka also we have data centers in multiple places. For an example, if you visit Homagama, they have the SLT's data center, and if you visit Union Place, they have the Dialogues data centers in multiple locations around Sri Lanka. So this is where the internet lies, right? For an example, the moment you request a web page from the internet, right? The web page is stored in someone's cloud computer, maybe in this sort of a rack, right? So you are requesting a resource, and the resource comes from this sort of a virtual computer, and that's what we basically are talking about here. How do we get access to this sort of a cloud computer? How do we get access to this sort of a server resource so that we can deploy our workloads on top of these machines, and we can easily deploy our infra on these sort of platforms. Anyways, moving back to cloud computing, like I mentioned, it's someone else's computer, right? We're utilizing someone else's resource to deploy our own workloads. So that is there. Anyways. So let's talk about the evolution a bit. So I really hate talking about history because that's some of the subjects that I hated during my school times as well. So I really hate talking about it, but today we really had to talk about it. The main reason is that history is not a history anymore, right? So when it comes to cloud computing, we can't really neglect any sort of evolution stage. So let me talk about it. So in the earlier days, I'm talking about like 25 years ago, we had something called physical machines, physical data centers. So what happened was basically people are using their own computers, on devices to host their own web pages. So if you know the very first website that the founders of the internet has developed, it was hosted on a personal computer like what they're using right now. It has very low memory and it was connected to the internet. And then they managed to connect two machines and send a message across a network. So that was the very first step of cloud computing. And the data traveled across the internet, and then they got that was the very first internet transmission that took place. And over the time, people found it that the personal machines are very messy. The main reason is that when you use some sort of personal machine, it's going to take a lot of resources, and the other thing is that you have to keep the power on 24/7. So that sort of issues are there. So we can't really do that, right? Because we have to keep our machines turned on for 24/7, and that's a hassle that people has to work on. So over the time, they came up with a concept called virtual machines. So what happened was basically just imagine you are having your own office space, right? In the office space, they managed to keep up the machines turned on for 24/7 up and running. And then as the employees were able to log into the office machines virtually, and then controls certain things, maybe to access certain resources of the on-prem of the office premises, maybe to access, maybe to deploy some web services, maybe to access certain web services. So those sort of things are made possible with the concept of virtualization. So that was the next stage of um, evolution, basically. So that was called virtualization. So that was really good because now people doesn't have to keep a machine running in their home premises. So they can access a remote server using this concept called virtualization. So the concept of virtual machines came up. So we are there running their machines and we can access using virtual machine protocol. The next concept called it's called containers actually. So what happened in that stage was basically people found out, okay, um, the machines are running, people are accessing remotely, that is great, but still there's issue. People are facing a lot of difficulties when deploying their applications onto the cloud. So that is one of the biggest issues that people faced when they're deploying. Even I know that maybe you all as undergraduates may be facing that sort of difficulty when you're deploying applications onto cloud resources. For an example, if you take, just imagine, I'll take a simple example. Just imagine you want to deploy a simple Spring Boot application. What you'll have to do? First of all, you'll have to install Java. Secondly, you'll have to install the JVMs, the runtimes, and configure the whole infrastructure and then deploy the application on top of the cloud service. That's a very big hassle, right? So to simplify the operation when it comes to deploying these applications, they came up with a concept called containerization, containers. So what happened was basically they are introducing like a virtual environment, which means we can define what is going to be the spec and what is going to be the resources that we're going to deploy on cloud. So which means, okay, so let's say as predefined, we're going to have Spring Boot installed. As predefined, we're going to have this sort of packages installed. So the spec is going to be always predefined, right? And the application is containerized, which means we are shipping the application from your local machine to the cloud with a predefined specification. So the cloud, the containerized environment was introduced in the next stage. And right now we are in the evolution stage of serverless machines. So serverless machine means is basically we don't have to take care of any of the hardware infrastructure because there are a lot of service providers. If you take Google Cloud, Microsoft Azure, AWS, and there are a lot of platforms that are available. Those are providing virtual environments where we can deploy heavy cloud workloads. So those sorts of things are there. So now we are at the serverless evolution. But here's the thing. So even though there's a history, starting from physical machines to serverless machines, we can't neglect the history. The main reason is that even though we are at the latter stage of the evolution, we are still utilizing the physical infrastructure anyways. There are a lot of use cases, right? For an example, just imagine if your data is very sensitive, you can't actually use a cloud provider, right? For an example, there are companies who doesn't even want to use a cloud provider. The main reason is that their data is very sensitive and they don't want their data to go out to a public cloud and then handled by a third-party cloud provider. So there are a lot of data compliances. For an example, if you take a healthcare company like Pfizer, I recently saw there's an article going on. Pfizer is using a massive cloud data center in the USA. So if you take a medical research company like that, they have a lot of compliance issues. So in that case, they are still using their own servers. And even if you take Sri Lankan companies, like if you take companies who are into finance and different other medical domains, very sensitive domains, they don't want their custom information to go out to a public cloud provider. So considering that, people are still utilizing this sort of hardware while we have the modern day technologies like serverless computing and containerizations and many other technologies that we are using right now. Even for technologies like LLM inference, people are using local servers as well. If you have the GPU resources and if you have the CPU and GPU resources, people can easily use these sort of local environments to inference local large language models as well. So just a small notice. So if you get any questions, even if it's outside of the scope of this workshop, maybe it could relate to some sort of a large language model related question, or maybe something to do with LLM inferencing, maybe something to do with any sort of other activity, feel free to drop your question in the chat. I'm I'm happy to address any of your questions while you all get during the session. All right, so now we're going to talk about a very basic concept. So this concept is known as CI/CD, continuous integration and continuous delivery, right? So this is actually the pipeline we have from code to prod. So today's session's topic is from moving your application from code, which is your IDE, to the production, right? So this is actually the high level architecture on how your applications could be deployed on the production levels of infrastructure and hardware. So this is where your code relies, right? This is your local machines code. And what you do is basically, I believe all of you are familiar with these two steps. You have your local machines code over here, and then you commit your code into a version controlling provider like GitHub, maybe Bitbucket, maybe GitLab, right? So there are a lot of source controlling providers. So I believe all of you are familiar with these two steps. So these are the two other steps we're going to focus about today, the CI pipeline and the CCD pipeline. CI pipeline is basically the stage that runs before the deployment operation, right? Deployment means, okay, the final stage that your application gets deployed onto a live server. That's the last stage. And before the last stage, we had a CI pipeline, which is known as continuous integration pipeline. So what happens here is that basically the moment you commit some work into GitLab or Bitbucket, we can automate this process. So what happens is basically, I believe all of you have heard of this platform called GitHub Actions. So with GitHub Actions, or even if you define something like Bitbucket Actions, or even if you use something like GitLab Actions, we can automate the whole process, like building process and running unit tests and integration tests, and you can do many other things. So it's not only limited towards these three actions, right? For an example, it could be a code quality check like SonarQube. It could be some sort of latency checks. It could be some sort of a scalability check. It could be some sort of a, let's say, load test, right? So there are different types of tests we can run. So not only these three actions, we have load testing, we have security testing, we have code quality checks, and there are many other operations that we could perform during the CI pipeline, and we could 100% automate these things, these actions. So how it works is that we can actually define the rules and guidelines basically on how it should run and what are the steps it should pass to getting to the next stage. So that's going to be the action plan of CI/CD pipeline. So that is there. And the next thing is that we have the CD pipeline, which is known as a continuous deployment pipeline. So in the CD pipeline, what we could do is in the CD pipeline, what we could do is basically we can focus on the deployment process. So how it works is that basically the moment the CI pipeline is passed, which means whenever the actions are passed successfully, we can run the CD pipeline to deploy your work on top of a real world, real running cloud computing instance. So before you talk about the deployment, the stage has to pass. This stage has to pass anyways, right? Basically, like building the container as a Docker image, maybe like properly creating artifacts, things like that has to pass before we move forward with the CD pipeline, which is known as continuous delivery pipeline. In that case, what happens is the container that is built on this stage will be moved into the CD pipeline, and the deployment will happen on top of a live server. So that sort of operation can be done on top of a CD pipeline. So the whole process can be automated from your code to the deployment stage itself. So you don't have to worry about, doing it manually. Because I have seen a lot of people who are, when you have a code base, you zip the code base together and you manually upload it to whatever the shared hosting or whatever is hosting provided. That's not a good approach to handle. So we can automate. That's how it works on the production level itself. All right, so we're going to be learning certain terminologies during this session. So we're going to talk about this platform called IaaS, Infrastructure as a Service, Platform as a Service, Software as a Service. These are the different terms of terminologies we'll be using during the session. So if there's any sort of clarifications that you guys wanted, feel free to drop your questions in the chat so I can address those during the session itself. All right, so I don't want to make this session biased towards GCP, even though I represent GDG Sri Lanka. I want to make it agnostic towards any sort of cloud provider. Could be GCP, could be Azure, could be AWS, or could be IBM, DigitalOcean. So I'm free to discuss any of these options that are available. So if there's any questions, I can answer any of these questions with regard to any other cloud provider as well. So anyway, I'll show some of the other options we have in hand as well, like Azure, AWS, IBM, and DigitalOcean. I'll mention what are the different types of services we have on these cloud providers. So small comment on the cloud providers. So right now, in terms of the cost, I would say DigitalOcean is one of the cheapest providers that is there. So DigitalOcean provides you a very cheap service. So if you guys have budget constraints, if you're looking at a cloud provider that offers you affordable cloud solution, I would say DigitalOcean is one of the cheapest and cost-effective budget cloud providers, so that you all can use it. If you're into like AI workload inferencing, IBM Cloud has a lot of infrastructure, because I believe that GCP and Azure has limitations when it comes to utilizing GPUs. But IBM Cloud has provided GPUs as well, but compared to these sort of providers, IBM Cloud is a bit expensive, but they are providing the infra for LLM inferencing, as well as GPU nodes, as well as GPU workload processing, things like that they are offering. So I would say if you're looking at an option where you can inference your GPU workloads and large language model kind of workloads, IBM Cloud could be one of the perfect places. So then we have AWS. So Amazon's most popular cloud platform. So AWS has a lot of solutions. For an example, they have the compute instances. They have an AI platform called AWS Bedrock. If you guys want to inference like pre-built small language models, not large language models, even large language models they support, but you will have to get a free quota. Even if you want to inference some small language models or vision models, they have a really great platform called Bedrock. So y'all can use that to utilize their resources for AI inferencing. The next service is Microsoft Azure. So far, GCP and Azure is my favorite cloud providers, because Azure and GCP, they provide you a solid foundation to deploy your infra on a cloud resources, cloud platforms. So it's pretty good. So they're providing a lot of services like compute to manage services, to manage Kubernetes, and many other solutions. So I would say GCP and Azure is my favorite platforms right now. So today we're going to focus more on GCP, but I'll talk about the other services in the meantime as well. All right, so talking about GCP, GCP provides you a lot of services, including compute instances. So let me talk about compute instances. For an example, it's more like renting out someone's machine to run your workload, right? It provides you RAM, provides you storage, it provides you GPU, right? So compute instance is like is a platform like that, where you could rent out some space from someone else's machine, from Google Cloud's hardware infrastructure, and you can run any sort of workloads, but you have to configure every single thing, starting off with the OS installation, to installing packages, to installing environments, whatever the services are. It requires you custom configuration. So in all of these cloud providers, even if you take GCP, if you take AWS, if you take Azure, they all have different services for compute. So on GCP, we call it as the compute engine. On Azure, we call it as Azure Compute. And then on AWS, we call it as EC2. Sorry, Azure, we call it as virtual machines. On AWS, we call it as AWS EC2 instances. So these are actually fully configurable machines, where we could install our own packages and customize it fully. In case if you're looking at a very high flexibility to run your workloads, I would say that's one of the best platforms you all can use to customize and install custom packages and get a lot of things done. Yeah. All right. Then we have Kubernetes Engine. So Kubernetes Engine is actually a really great container orchestration platform. if you're looking at a higher scalability, let's say if you're looking at multiple microservices driven systems and let's say multiple service-oriented architectures, I would say going for a Kubernetes-based system is one of the perfect choices you all can make in your lives ever. And if you take AWS, they have the AKS solution. They have the EKS solution. And on Microsoft Azure, they have the AKS solution, the Azure Kubernetes Service on that is there. And on if you take AWS, they have the Elastic Kubernetes Service. So all of these Kubernetes providers are there. So in case if you want to deploy your application on Kubernetes and orchestrate containers to deploy microservices, to deploy different types of services on Kubernetes, feel free to use the Kubernetes engine to do that basically. And then we have App Engine and Cloud Functions. So those are actually managed services, which means, let's say, without having to manage any sort of a hardware infrastructure, we could use Cloud Functions to create your own function, a serverless function, and deploy on their platform. So that is there. And also we have a wide range of management tools. So in case if you want to monitor the cost, monitor the hardware resources, RAMs and CPUs, GPU utilization, right? We have a lot of management tools that we have on GCP platform. So we could easily use these platforms to keep monitoring our resources and get many things done. And even for AI, so we have a great stack provider from GCP. Now they have a platform called Vertex AI. So Vertex AI is actually the rebranded edition of Google's AI platform. So they are providing access to many of the models, many of the modern day models. Even if you take their competitive models like Llama, and if you take even the DeepSeek models and even Llama models, any sort of open source models, they are providing access to those sort of models as well through their Vertex AI platform. So that is the rebranded edition. So now there are a lot of things happening on top of Vertex AI platform, which we could use to properly run our workloads on top of platform like that. Right. So now let's do a little bit of a comparison before we deep dive into each of the application. Let's do a little bit of a comparison to understand what is special with this and what sort of advantages we have if you use each service. So let's understand what are these, right? So first one is the compute engine. So like I mentioned earlier, it's more like renting out someone's machine. For an example, let's say you want to hire your friend's machine, which has 8 gigs of RAM, two vCPUs, and one GPU, right? To run your own application. But why do you need to rent out your friend's machine when you can do it on cloud? So Google has provided that option, right? Like I mentioned, we could easily sign up for a GCP account. We can easily create a compute instance on GCP, and we could run our workloads on top of the compute engine. So I'll be doing a small demonstration on how you could set up a GCP instance and how you could set up a compute engine instance on GCP and how we could set it up. So that I'll be demonstrating shortly. That is there. And like I mentioned, GK is a Kubernetes platform. Like I mentioned earlier, if you want to inference any sort of a cloud workloads on containerized applications, we could use GK platform, the Google Kubernetes Engine platform, to get it done. And then we have this App Engine. App Engine is actually it's a platform that you can deploy standalone applications. For an example, if you take something like a Node.js application, if you take something like a Python application, you can do a managed deployment, and yeah, that is up to some level, it's free of charge as well. And then we have another interesting platform which is known as Cloud Run. So Cloud Run is actually one of the Google managed platforms to deploy containerized applications, right? So the main difference between GK and Cloud Run is that on GK, we can deploy multiple applications in the same environment. For an example, because it's Kubernetes driven, which means it orchestrates multiple containers in a single cluster. And we can even create the coordination between multiple microservices, right? So that's the main difference between GK and Cloud Run. Cloud Run is actually a singular way of deploying and running a compute container on top of the GCP platform. It's a singular way, right? GK is a multiple way. If you have multiple microservices you are planning to run on GCP, you can use GK service. But if you are planning on running a single application in the most simple way, I would say Cloud Run would be the go-to option, the perfect option for you, right? So the setup is actually very simple. I'll show you during the demonstration. It doesn't even take 5 minutes to set up Cloud Run. It's very straightforward and it's very easy to set up. So I would say if you're looking at deploying a simple application, Cloud Run would be the perfect choice. So yeah, so we have all of these options right now. So the next one is Cloud Functions. Like I mentioned, if you're looking at a serverless way of deploying different types of functions without having to manage your hardware infrastructure, Cloud Functions is a really great place. The main reason is that they are charging you on API call basis. For an example, for million calls, they are charging a small amount. Even if you take like for different functions, we can use Cloud Functions. So for an example, just imagine you are riding on Uber, right? So at the end of the Uber ride, you are getting your own bill to your email, right? Saying that, okay, yeah, this is your amount and these are the payment methods and this is your distance and this is your rider, right? So you're getting all of these things right after pick me or Uber ride. Have you all ever thought of how it happens? Because there are a lot of automated triggers. So on Cloud Run, we can set up those sort of automated triggers as well. Sorry, in Cloud Functions. So the triggers can be made automated and we can set cron jobs and we can set a lot of automated triggers and things like that. So to automate the whole operations without having to manage a backend operation. But they're charging you on single API call basis. So per million requests, it's a different amount and depends on the volume it scales up. So those sort of things are provided. Right. So now let's talk about Compute Engine. So I already discussed about what's the difference between Compute Engine and the other services. So like I mentioned, it's more like renting out your friend's machine. So without discussing more about it, let me straight away go into the demonstration. So you will have understanding of how you could actively use Compute Engine and deploy your workloads and to set up a machine. So let me show you a real world demonstration now. All right. So y'all can actually try out with me. Y'all can scan this QR code. Y'all can take a screenshot of this, or you can access this link straight away. So to access this platform, and there's a CodeLab given. You just need to access this CodeLab. You can just copy and paste this link, and maybe even later after this workshop, you guys can follow after this as well. This has all the step-by-step guidelines on how to set up the Compute Engine instance of on GCP, Google Cloud Platform. Let's see how we can do this. So to do that, you need to access GCP platform first of all. So you can go to Google and search for GCP, and this is what you get. And from here, you can access GCP platform completely. And then there's an option called console, right? So when you're logged in with a Google account, it will give you this option called console. So from here, it will take you to the GCP dashboard, right? So this will have all of these options for setting up different types of virtual machines and billing to different services and many other things. So if you want to set up your own account, you can do that. And there's a small requirement when you're setting up a GCP account. It will ask you to provide credit card information, right? GCP requests you to provide the credit card information or the debit card information when you're setting up the account. But don't worry, it's not going to charge you anything unless you exceed their limit. So they are providing you 300 USD of free credits for a time span of 3 months. That's going to be the limit. You'll have to work on. The trial is some around 300 USD of free credits for time span of 3 months. So you guys can apply for the credit and you all can actually experience their platform free of charge. But don't worry, at the end of this session, like I mentioned earlier, I have 2,000 of credits waiting for y'all. If you are running a product-based startup, they are providing you 2,000 of credits that we can get it approved from Google team. So yeah, that I have as offering. Anyways, once you do the sign up process correctly, you will land here. And then you can search for this service called compute engine. Yeah, so you can access this platform called Compute Engine, and then you can see there's something called Create Instance, right? So along with Create Instance, there are many other options. You can see there's something called templates, and there are different types of instance sizes, and there are many other things that are available. So you can actually simply create an instance by clicking on this option called Create Instance. That will that will lead you to the process of creating a GCP instance. First of all, we'll have to enable these APIs. So you can see it says compute engine is disabled. So I'll just enable it right here. All right, so let's see what we have to do next. So the next thing would be to create the GCP instance. Let me switch it to a different project because I don't have a billing account. So billing account means you should have a valid billing account with the credit card linked to access the virtual machine environment. So what you could do is you can go to this option called virtual machines, total VMs, and then I can click on this option called create instance. So I have 3 instances running at the moment. So I'll not interfere those. So I'll create a new fresh one. I'll just give it a name, like let's say workshop 1, something like this. Right. So then from here, you can see we'll have to make a certain decisions, right? Choosing the region and choosing the zone. So why region is important? Um, this is a compliant requirement. For an example, if you think about Europe region, they have very strict data protection regulations. For an example, they have the GDPR Act in place. So they are very concerned about where are they going to store this data, right? They don't want their data to go out to a different region like US or Singapore or Asia, right? They don't want to do that. So they're very concerned. So even if you take Sri Lankan companies who has strict data protection regulations and compliances, what they could do is basically they could choose a region from the Asian region or Europe region, based on whatever the compliances they have, they could choose their own region. See, for an example, if I go to Asia, they have the closest service that we have is from Delhi and Mumbai in India, right? So we can choose either Mumbai or Delhi. So I'll go with the Mumbai server because choosing the closest server has an advantage, right? So because if you take the internet latency, the time it takes to retrieve the information is very shorter if you choose the closest server. For an example, if you choose a US-based server, it's going to take a little bit of additional time to load the information. But if you take a server in the Asian region itself, in the same region that we are accessing from, it's not going to take a lot of time to load the information. So I'll just go with the Mumbai server, and in zone we can choose a zone like this. They have multiple zones, and then the next step would be choosing the machine specification, right? So from here you can see there are a lot of machine specifications. They have low cost machine instances for data computing, and they have compute optimized machines, they have memory optimized machines and storage optimized, and even the machines with GPUs, like I mentioned. If you're looking at the inferencing small language models, right, or even large language models, they support GPU instances as well, so you could choose accordingly. Right. So you can choose the machine category over here. And if you want to learn more about it, GCP has their own documentation. So on the documentation, they have the compute engine documentation. So under this, they have mentioned what are the differences of each machines. If you properly, yeah, if you go through the documentation, you can find the differences of each machine and how to choose it. That sort of guide is provided. So you can actually go through this documentation to understand the different types of machines that are there. Right. So next thing is the machine type choice. So from here, you can choose the machine type here. So you can see I have already chose a machine with 2 vCPUs and 4 GB of memory. and you can customize this if you want a custom requirement. Let's say you can put different types of vCPU, the core count, and even memory. So I'll just pick something like 2 vCPUs and 4 GB of memory, just for my demonstration. Right. So the next option is basically choosing the hard drive, hard disk, as well as the other stuff basically. So if you go to the next section, you can see there's something called OS and storage. So from here, you can actually set up the OS. So I recommend for most of the use cases, going ahead with Ubuntu based or Linux based OS is the perfect choice for system hardware and for system virtualization. But if you require Windows machines, you can do that as well, but you need a license. So if you have the license to use a Windows server, you can do that as well. Or you can choose a Ubuntu-based machine. So I would recommend choosing OS like Debian or Ubuntu would be the perfect choice if you are a beginner to get started with the virtualization techniques. I would say Ubuntu would be one of the perfect choices you all can make when you want to start the machine instance. The size, of course, you can say, let's say 20 GB, right? Because anyway, for the OS itself, it's going to take some around 6 GB. So I would just go with 20 GB to be in the safe side of it. Right. Done. So data protection, if you have any sort of protection mechanism, let's say if you want to have frequent backups, snapshots, you can actually set up the replication strategies as well. So in case if you want to, have a fallback mechanism in case if something goes wrong with the information, the backup plan could be there. So yeah, those things can be set up. So the one more important thing, you can see the monthly estimate, which is the cost. So you can see the cost is somewhere around $53. It depends from machine to machine. So if you go for a lower spec, the cost will be lower. For an example, if I just go here and make the memory 3 GB, you can see the cost will be increasing. Yeah, so now it's reduced by in point form. And even if you go for a cost-effective machine, something like N4D, we can actually decrease the cost based on the usage. So there are actually different types of machines. Some machines are very costly and some machines are cost friendly. So depending on your choice, you can actually go for a cost friendly machine. So this is an expensive one, and you can choose whatever the machines which has the least cost for your requirement and the most matching one for your requirement itself. Okay, I'll just go with this. I'll go with info, right? It's all right. I'll just go with this machine choice itself. Let's see the cost. All right, it's available. It's $30, right? Don't worry. You still have 300 USD of free credits the moment you sign up if you want to try it out. So you can experience it later. Right. So I'm going to create the machine. Let's see what happens. All right. So now you can see the machine is being created, right? It's right here. So it takes about a few seconds to provision the machine. So you can see it's creating the machine, staging, and it will provision you a public IP address where your public clients can access the machine itself. So it will provision the hardware, it will provision the disks, it will provision the OS and every single thing. And let's wait for a couple of seconds until it loads, right? And now it's running. So let's go back and see the public IP. So you can see there's something called internal IP and the external IP. So internal IP is basically if you have an internal network like a virtual network, we could set up the internal IPs as well based on your requirement. And the external IP is basically the IP that your clients could access your machine. So if I copy this machine and the IP and paste it over here, let's see what happens. Nothing happens, right? Because there's no configuration in the machine right now. It's an empty machine, which has nothing installed, but they have Ubuntu installed by default, so it won't do anything until we configure the machine itself. Right. So now, how do we access it? How do we configure this now? So that's going to be the problem. How do we transfer files into this machine? there are a lot of questions I know that I'm sure that you guys have to clarify. So the perfect way of configuring a virtual machine is that using the protocol called SSH, Secure Shield Protocol. So which is known as SSH. We can SSH into a virtual machine and we can customize the environment. We can install packages. We can update the instances, and we can do a lot of things. So you can see GCP provides you two ways of accessing the machine on their platform. One way is that they are providing you a browser-based SSH as well. So if you click on this option called SSH, it will open the SSH client on the browser itself, so that we could, configure the machine on the browser itself. If you don't have any sort of softwares to work with, we can configure the whole machine on the browser itself. But if you have the softwares like the local terminal, the softwares like Putty. There's a software called Putty, or you can even use the local terminal to configure the machine as well using the private keys. You can do that. But if you want to configure the machine on the browser itself, yes, that's also possible to do that basically. Right. Now let's try to install some packages and see whether I can make this IP public and whether I can serve an actual website on this virtual machine itself. So let's go to the step-by-step instructions now. So now you can see in step number 6, they have given the instructions to update the machine and install this package called Nginx, right? So let's first of all use these SSH terminals, the Ubuntu commands, to access the machine and run some updates and to install the package called Nginx, right? So with the command of apt update, we can fully update the machine, the software packages. We can fully update with the apt update command. And then we have the apt install y nginx. With that command, we can easily install the nginx package. So what happens is basically nginx is more like a way of making your application a server, right? So now, before I install nginx, our machine wasn't a server. It was a server, but the server wasn't available to public. So if you want to make your server available to public, there are multiple options. There's something called nginx service. There's something called Apache service. There's something called Tomcat service. Um, there are a lot of other options as well. So if you want to make application server, you could do that, right? You don't Nginx one of the servers. So Nginx supports a lot of frameworks and it can work as a reverse proxy as well. If you want to host HTML websites, PHP websites, even to host Node.js applications to serve in a domain as a reverse proxy, Nginx supports that. So Nginx is one of the most powerful server applications you can use to serve your applications to a public world. So we could do that basically. Right. So now that Nginx is installed, let me start the service and let me run this command to start the Nginx service. Now it's running. Now let me see if I can still access the service. Let's refresh and see. Still nothing, right? Still nothing. It won't work. Why is that? Because of the firewall, right? The firewall is protecting and it won't let the public users to access our application because the ports are blocked, right? So if you want to unlock the ports, you can actually access the machine from here. And then you have to go to this section called network, right? You can just click on this option called edit first of all. Under the edit option, there's something called networking, right? So under the networking, they have an option called firewalls, right? So right now they're preventing access because see, for an example, if you want to give public access to your virtual machine, right? The public has to be able to access certain ports. For an example, the HTTP port, the base port, the HTTP port, and then we have the HTTPS port, the secure port basically. So these options are there. So what you could do is basically you could allow these HTTP port and HTTPS port, and then you can save it, and it will take a couple of seconds. Let's see what happens. All right. So now it's saving. Let's refresh one more time and see. All right. Now it's loading, right? So now you can see I have allowed these two ports from the firewall itself. Firewall means it's a way of protecting unauthorized access to your server, For an example, when you have a web server running, there are different ports that has to be configured. For an example, port 80 is the default port of HTTP, the hypertext transfer protocol. And if you take port 443, is basically the port for HTTPS, the secure version of HTTP. So you can enable these ports. And for an example, if you're using any other services like databases, let's say if it's MySQL 3600, if it's Postgres, it's 5,8775. And if it's something like SIP, it's 5,600. Likewise, you have different defined ports for different services. So like I mentioned, HTTP is by default port number 80. And if you take HTTPS, it's port number 443. So just like that, we have different ports for each services that we could enable and disable. So right now I have enabled both. Now the application works. So let me drop you this IP address in the chat as well, so that you guys could see how it works. And let's see. All right, so let me all right, I have dropped the IP address in the chat itself, so you guys could see how it whether it loads on your browser, so you could see that. All right, so let me make a small change in the website. So now you can see it's a welcome page of Nginx. So let me go to the server and change it basically. So by default, Nginx has their default location of serving web pages, right? So usually in a virtual usually in a Ubuntu server, they have a default location of keeping the files of a web page of the welcome page basically. So it's called var triple w html. So this is going to be the default directory where you can store your files, right? So I'll just go ahead and delete this default file with the remove command. Right, now it's removed. So let me create the index.html file. I'll just add some basic HTML tags, just like this. I'll say for the title, I'll just say something random. I'll just say workshop. I'll have a body as well. Something like this. All right, let's save it. And now if I refresh, you could see my sample web page is loading, right? It says welcome to the workshop, and you can see the title is also there. So just like that, you can move your web page or what is the application contents into the root directory, and you can simply work on the rest. So that those sort of things are provided basically. And not only the root directory part, you could run many other applications. You could run Node.js based applications. You could run Java based applications and Python based applications. Just like that, you can make it a server and serve it on a different custom port. So those sort of operations are possible. And the next thing I had to mention is that on the um, file transfer side, basically. So now you all might be wondering, okay, how do I put some files into this sort of a cloud environment? There are multiple ways, right? You could either use a FTP client, like there's a popular one called FileZilla, one of the most popular HTTP clients. It's a free software that you could use to transfer files into a virtual machine. And then you can enter the machine's credentials, you can enter their IP address, the security keys, and you can authenticate. These are really great software that you could use to transfer files into a virtual machine. And then there's another one called WinSCP. If you're using Windows, you can actually download this software. It's free of charge for Windows users. Yeah, if you're a Windows user, you could download this software called WinSCP to do the SSH configuration plus the file transmission all in single place. This is a really great platform. And if you are a Ubuntu user, or even if you're a Windows user, they have another option called PuTTY, PUTTY. That's another great software that you guys could use to connect into a virtual machine. PuTTY is there. But if you are a native user, you guys could easily use your terminal itself, your local terminal, maybe the command prompt to access the virtual machine with the terminal itself. So that sort of things could be done when you're setting up virtual machine instance. Right. So let me quickly go through some of the other techniques as well. For an example, there are different concepts, right? So I believe all of you have gone through A-levels, right? So during A-levels, what happens, right? The moment we get the result, what happens? We go to this website called DOE and ETS.lk, the Department of Examinations website. And when we try to access our result sheet, right? What happens? It takes forever to load, right? So I think even today there were some results released. So it takes forever to load and sometimes it crashes, right? Sometimes we can't access the page at all, basically. So what's the reason behind that? So when you get unexpected traffic from all over the Sri Lanka, that sort of a behavior is normal, right? For an example, just imagine you are traveling in the baseline road at about 2 p.m. on a weekday. Even if you take the gold road at about 6 p.m. or 5:30 p.m. on a random Friday, you can't even travel, right? Why? On a normal daytime, you can easily travel without any traffic. You can even go at 60, right? If there's no traffic. But if you take at about 6:30, you can't even move. You can't even travel by a tuk, right? You had to wait for a very long time in the traffic. So that sort of issues are there, right? So why is that? So the main reason is that the site wasn't load balanced. Load balance as in the site wasn't ready for a heavy traffic actually. That's the main reason why you could not log into that sort of website. So in the cloud computing concept, we have an interesting concept called load balancing. So load balancing is actually, it's not a magical thing, right? We are not going to expand the hardware um, in a magical way, but there are logical ways of handling that, right? So how are we going to do that? There are two concepts of load balancing. First one is called horizontal load balancing. The second one is called vertical load balancing. In horizontal load balancing, what happens is that basically the moment you get the traffic, just imagine your one instance, the instance that you just created, which is the workshop one instance could handle, let's say, 1,000 concurrent users. Just imagine that, right? I'm just giving a hypothetical number. Just imagine the workshop one instance could allocate somewhere around 1,000 users. That's the maximum, right? And let's say you are expecting millions of users. So what should happen, right? Because we predefine the hardware spec. We mentioned that, okay, my hardware limit is 4 GB of RAM, 2 vCPUs, right? It can't magically increase, right? There has to be a logical way of handling that. In horizontal load balancing, what happens is basically it will make a duplicate of the same machine, right? It will make a duplicate of the workshop one instance, and then all of these packages I just installed, the Nginx package and whatever packages that I have will be duplicated into the next machine itself. So now I can accommodate 2,000 users, right? First machine would handle 1,000 users. Second machine would handle another 1,000 users. So altogether, I can handle 2,000 users, right? So, but I'm expecting millions of users. So what will do is basically it will keep on creating multiple machines, right? It will million divided by 1,000 is 1,000, right? So it will keep on creating 1,000 other machines, and then it will distribute the traffic, right? So how does this traffic distribution works? There's this concept called load balancer. Load balance is basically the entry point, right? All the traffic comes to the load balancer, and the load balancer will direct your traffic into the current direction. It's more like how the police handles the traffic in the Tummula Junction, right? If you've been in the Tummula Junction in a random on a random weekday, right? Sometimes police will direct your vehicle to go in the 120 route. Maybe sometimes they will ask you to take a different route to go, right? When the president is arriving, sometimes they close these roads and direct you into alternative routes. Just like that, there's this concept called load balancer. The load balancer will take care of your traffic and it will allocate into the correct instance basically. So that sort of a traffic distribution will work. So yeah, so that sort of a things are possible with the load balancing concept. So you could set up a load balancer with GCP as well. Even if you're not using something like GKE, the Kubernetes engine, You can simply set up a load balancer on the Google Cloud, the compute engine service as well, basically. Um, you could set up a load balancer on compute engine as well, basically. So you can see if you go to this documentation, right, they have this option called Create Network Load Balancer. Um, you can set up a scaling group, which means you can set up the ways of scaling your machines, how it should duplicate your instances, and how it should direct the traffic into the correct machine. So all of these rules can be defined if you use the network load balancer. They have provided on the GCP platform for compute engine machines. But if you're using any other providers, for an example, if you take EC2, if you take something like Amazon, they have the application load balancers and network load balancers as well. So we could use either any of these application level load balancers or network level load balancers to make sure it goes to the right instance without having to interrupt the process. So yeah, that's the next concept, load balancing, how it should distribute your traffic into the correct instance basically. Right. So all of these things you could try. Like I mentioned in the documentation I just shared with y'all, it has all of these step-by-step guidelines that explains the whole holistic picture of how these load balancing techniques should work. So yeah, let's move forward to the next point. So anyway, I'll take up some questions we have in the chat. There's one question. Okay. First question is called, okay, does NI10 falls under CI/CD tools? No, we can't consider NI10 as a CI/CD tool. It's a AI agentic platform where we can use to build agentic workflows. So we can't consider that as a CI/CD tool. So if you are looking at CI/CD tools, there's a platform called Argo CD, which handles deployments. And there's something called Travis CI that will handle the CI pipeline. And we can consider GitHub Actions as a CI tool as well. And we have another tool called Jenkins. So these are the CI and CD tools we have. And then there are many other tools that we could use to, and there's another one called Flux CI. So all of these things are the CI/CD tools that we can use, but N10 would not be considered as a CI/CD tool. It's a AI agentic workflow builder. All right. Any other questions? Okay. SageMaker. Yes, that's a larger platform. All right. Okay, so I'll continue. So feel free to drop your questions. So I'll answer it during the session itself. All right. So, all right. The next thing, the next part is basically on the App Engine. So App Engine is actually one of, so it's right now it's been depreciated, but people still use it. Those who have legacy accounts. So App Engine is actually a managed way of deploying applications. So which means if you don't want to worry about the infrastructure, if you don't want to worry about how much of RAM you should allocate, how much of CPU you should allocate, and if you're only considering about the application level, keeping the application up and run all the time, App Engine would be the perfect choice for that sort of option. But now there's a better alternative. For an example, like I mentioned earlier, Cloud Run is one of the better alternatives we have for managed services for application deployment. So I'll talk about that later. If you're looking at the alternatives for App Engine in other cloud providers, on Azure, we have the Azure App Service, and then we have another one called Azure Static App Service. So those sort of tools could be used to deploy static applications on different cloud providers. And then if you take AWS, there's something called Lightsail. Lightsail is one of the services that sorry, we have Amplify. So on Amplify, we could deploy applications on a managed basis, basically. Right. So now we are coming into the interesting part, right? So we're going to learn about an interesting concept called containerization, Dockerization, as well as container orchestration. So we are coming to the interesting part, and we have a practical demonstration of that as well. So you guys could follow up with me. So yeah, let's move forward. So um, on Cloud Run, we could do a lot of things, right? First thing is that Yeah, give me a second, guys. All right, sorry about it. So let's talk about the difference of Cloud Run versus App Engine, right? So App Engine is actually a way of deploying application without containerizing. So what I meant by that? So I mentioned about the containerization concept in the very beginning of this workshop, right? So containerization is basically like creating your own environment. It's like creating a setup for a game, right? For an example, if you guys are playing games, there are multiple ways of installing, right? You can just double click on the exe file and install that, or you can double click on the MSI file and install a game. So even if I'm installing a software, even for macOS, even for Windows, whatever, we just double click on the setup, the DMG file or the exe file or whatever the file, we just double click on the software setup file and we install it basically. So that sort of things can be done. Just like we come up with the installer for different types of applications, um, we have it for the backends and front-end services as well, where we can containerize. So containerization means basically we are creating the environment virtually. So let's talk about that, right? So on Cloud Run, we can deploy these containers. So let's understand what are these containers I'm talking about, right? I was talking about containers. So you all might be thinking, am I talking about the containers in the port? It's not. Let's understand that. All right, so this is how the workflow happens. So first of all, these are the developers who are programming. And then what they do is basically they create a trigger. Trigger means the moment the code goes to GitHub or Bitbucket or whatever the version controlling platform, it will trigger build. So build means it will build the entire application as a Docker container, right? It's going to create an enclosed environment for the application itself. So after that, what happens is basically the container goes to Cloud Run platform and the deployment happens. And after that, the public users can access the application via the Cloud Run platform, and they can use their APIs. They can use whatever the platform, the features they have given in the application. The external people could use it basically. So that sort of thing could be done. Right. Right. So I have another question. I'll take up that. Which CI/CD tool would you recommend to focus on basically between GitHub and Jenkins? Solid question. So I would say there are pros and cons. I would not give a recommendation here, but I'll give my opinion. So you can actually decide which one to choose, right? So GitHub Actions is basically like a managed version of running a build pipeline. For an example, if you want to create the Docker image on GitHub's servers itself, you could use GitHub Actions. And they allow you to bring on third-party runners as well. For an example, on GitHub Actions, without using the GitHub servers to build the application, we could actually spin up a third-party Jenkins server and link it to the GitHub Actions also, right? So GitHub is a managed platform. Jenkins is an open source platform. It's a software that we could use to build our applications basically, right? So we can even inference Jenkins application on a dedicated machine itself. We could use a virtual machine to install Jenkins, and we could use that as a build server, right? Also, we had the feasibility of linking up a Jenkins server into GitHub Action also, so that GitHub would GitHub wouldn't have to use their servers. Instead, the application would be built on top of our server itself. So Jenkins can be considered as a build server, which is really good. So we can't really compare, like I mentioned, we can't really compare those two together. But I would say simply GitHub could be known as a managed service, easy to set up. And data integrity wise, there's a small issue because GitHub is going to have the ownership of the whole build pipeline. So while Jenkins would have our ownership because it's an open source platform that anyone could deploy on their own servers infrastructure itself. All right, so moving back to my presentation on cloud build. So like I mentioned, following up that question itself, Google has their own build server. Just like GitHub and Jenkins, those are providing build servers, Jenkins being an open source provider. Google Cloud Build also one of the build service providers basically. So what happens is basically the moment you push a code into a repository, if you want to make that a Docker container, Cloud Build could be used to do that purpose. So we'll see that in action on how it works properly. All right, so I want you all to take a screenshot of this. I'll share this link with you all as well. Yeah, you guys could take a screenshot of this QR code and I'll send this link as well. So let's see, let's move forward and understand the other concepts that we have. So before I talk about the Cloud Run in specific, I'll talk about the containerization with a practical example, and then I'll move into the Cloud Run demonstration. I'll show you all how it works, how it containerizes application, and how it gets deployed onto a real cloud environment. So let's understand that. Perfect. So let's talk about containerization. Just imagine you guys are export of, let's say, export of plants, right? Pala export can. So how do you export that? Can you transport these plants in a normal container of a ship? No, right? What happens is with the heat and all, with the different weather conditions, and with the different scenarios, the plant has to face inside the container with the heat and with the less humidity and every single thing. What happens is the plant will die whenever it arrives in the destination port, right? But there are several ways of preventing that. For an example, you guys might have seen if you go to a port, they have containers with different conditions. For an example, there are containers with air conditioners, and there are containers with humid controllers, and there are containers with different types of other configurations as well, right? That will persist the state of the environment that is required to hold the plant correctly, right? Because you can't ship a normal plant in a normal container, a container that you say in everyday life, you can't do that. So you need specialized containers to do that. Just like that, for applications also, we could do the same, right? So we could actually create the environment that is needed to run this application, and we could ship from one destination to another location. Let's understand that more. Just imagine you guys are working on a group project, right? One guy being the front end developer, another guy being the back end developer, the third guy being the ML developer, right? So what happens there is basically you guys are running three applications, right? First guy runs the API, maybe that's written with Node.js. The second guy runs the ML model written with Python. Third guy runs the front end written with React, right? Three different architectures, three different configurations. Just imagine the front end guy wants to do a integration between the back end. So what happens is basically the front end guys tries to run the back end guy's code in their machine, and then what happens? It goes to error, saying that, okay, your front end is using Node.js version 18 and your backend is using Node.js version 22, and you can't run either one. Either you had to, change it to 22, either you had to change it to 18. So what happens? So you need to have multiple Node.js versions, right? Sometimes you need to uninstall the Node.js version and then reinstall. Sometimes there are a lot of other solutions as well, but still you might face difficulties when running this sort of application on top of a server on a single machine, right? Why is that? Two different environments, not the same environment, right? Your machine might have Node.js 18, the other machine could have the Node.js 22. So based on the different types of environments we have, the application might or might not work, right? So how do you achieve that? So now, before I talk about the technical elements of the containers, I'll talk a bit about the virtual machines, right? Can I see a raise of hands? Those who have heard of this concept called virtual machines, maybe you all have worked with that. Can I see a raise of hands on Zoom? Okay, one. Okay, a lot of people. Great. Okay, so virtual machines is not a old concept. It's not a uncommon concept. It's basically how you set up two machines on the same machine. So it's not basically dual booting, right? It's basically setting up another guest OS on top of your current OS. For an example, let's say you guys are running Windows, and on top of Windows, you are using software like VMware or VirtualBox. to install another OS like Ubuntu or something else. So I have seen people are using Windows to inference like Hackintosh kind of OS as well on by using something like VMware or VirtualBox. I have seen people doing that. But the main difference between VMs and containers is that VMs would have the OS as the most parent level, right? For an example, if I create an image, right, it's going to have the OS as the OS as a parent container as well. So which means it's going to be very heavy, right? You can actually create a virtual image, a virtual machine image of your application as well. But the thing is, the biggest issue is that it's going to be very heavy because of the OS constraints. OS is usually considered as very heavy. For an example, if you build the container with Windows, OS is only going to have somewhere around 50 GB of memory, right? That's not a good way of shipping your application into the second client. And if you take the containers concept, we don't ship that with the OS itself, but we instead of that, we ship that with the application dependencies. For an example, just imagine you guys want to run your application on a Node.js environment. We could actually use the Node.js base container image and ship your application. For an example, just imagine your application is written with Python or any sort of ML kind of application. We could have the Python as the base image of your application and we can ship it properly. So let me show you something, right? There's a website called Docker Hub. So you could access this. This is actually called the central container repository of Docker, right? So you could see there are a lot of types of base images we have here. We have TensorFlow, PyTorch, LangChain, Python, right? There are a lot of types of base images we have here. So on Docker Hub, what we could do is basically we could choose any image. Just imagine your application is written with Node.js. So what you could do is you can come here and you can search for Node.js and it will give you a lot of resources. So you can see there are a lot of versions of Node.js that are available. So you can actually see the number of downloads they have. And based on that, you could get the most popular one, I would say. So you can see this has the most number of downloads. So you can actually install that. It's from the official Linux Foundation. So you can use an official, you can actually use an official base image to inference your application. So let's talk more about that, right? So like I mentioned, Docker Hub being the central repository, the most popular central repository of storing the container images, we can even publish it here, right? For an example, if I have my own container image, I can publish here. For an example, if I want my sub-developers, let's say co-workers to work on my environment, I can create my own environment and I can publish it over here. So those sort of things can be done so that the inheriting can be done. So you can even build on top of a Node.js based image and you can keep on improving and you can install your own packages and you can customize that fully. So those sort of things are being handled with the different types of images we have on the Docker Hub registry. Right. So let's try to understand it further. So usually, what happens is basically just imagine you guys are building your own application, right? On a local machine. So what happens is basically it's going to take a very long time to build. So we never do that, right? So in the cloud environment, we usually use a cloud-based building architecture, like maybe something like Google Cloud Build, maybe something like GitHub Actions, maybe something like Jenkins to build our application. So we never use some sort of a local architecture to get it done. So that's why we have a lot of providers that are providing the virtual building capabilities like GitHub Actions and Cloud Build, things like that. So let's talk about the Docker, the containerization process basically. So how do you write the configuration? So I'll take a sample Python application as an example, right? Just imagine your application is done with basic Python Flask. And what happens there is basically you need to ship your Python application from user A to user B, right? So how do you do that? So first of all, you need to pick the most appropriate container image basis. You can access Docker Hub and search for a Python image. right? So if you search for the Python image, you can actually see this is the Python image they have given, the most popular one. And then if you go to the images option over here, you should be able to find out different versions of Python, Python 3.12, Python 3.10, 3.7. Likewise, we should be able to see a lot of Python versions that are compatible with different types of applications, right? So what you could do is, based on your preference, based on the application's preference, you could choose a base image. So in my example, you can say, you can see in this sample, I have used Node.js as the base image. So base image means it's more like a parent to child inheritance. I'm inheriting all of the attributes of Node.js in my environment, in my architecture. So if I choose Python, which means I'm inheriting every single characteristics which is there in the Python-based application. So in my application itself. So that sort of thing can be done with the base image concept. And the next thing is basically defining the work directory. So you can actually mention, okay, what is my application folder? Depending on your source code arrangement, you can define a directory like this. And then you can give instructions on how to copy your files into cloud. For an example, do you want to copy any sort of specific files into the image itself? And then copy dot dot means I'm copying every single file from my application into the image itself. Sometimes we have about restrictions, right? We don't copy everything. So depends on the preference. We could actually do this and then installing dependencies. So the steps has to be properly defined. Right. So now, if you guys want to find out all of these commands, you can search for Docker commands. So they have given a cheat sheet as a PDF. So you guys could use this. This has almost every single thing on how to create the containers and how to build the containers, and all of these things are there. Cheat sheet is there. So if you want to see the programming reference under the Docker documentations, they have given every serialization process and the commands and everything's are there. So yeah, feel free to do this. And there's another site called Docker Playground. If you guys want to learn about Docker and its commands, you guys could actually go to this option called Docker Playground. It has something called Play with Docker. So you guys can execute their Docker commands and try to work around that and try to understand certain concepts of using Docker and try to, in a gamified way, you guys could play with Docker. So yeah, there are a lot of things you could do with this basically. All right, so now let's go into code example. Let's try to understand the sample code. Right. So I'm in my application. So you can see I'm actually, it's a very basic Python Flask application, right? So what happens is it will spin up a simple Python Flask server and it will basically, run a simple Python Flask server with sample endpoints. That's it. Very simple, very straightforward. So let's try to understand how we could deploy this sort of application onto a Google Cloud managed platform like Cloud Run, and how we can containerize this, right? So now you guys could see, I'll give this repository as well. Let me share the link in the chat so you guys could use it as well. Yeah, I just shared the repository link in your chat, so you guys could get the source code and you guys could clone it and you all can play around it. So yeah, this is how the code is, right? Let me go to the Docker file, which has every single configuration that has to be there to run your application, right? So like I mentioned, this is a Python-based application. So in that case, I'm using this base image called Python 3.11 Slim, right? So Slim is actually a lightweight version of Python. So you guys could see that in the Docker Hub as well. If you access that over here, there are multiple versions of Python, like I mentioned. There are major versions and there are minor versions altogether. And what happens is basically you can see it says from Python 3.11 Slim, that's the base image. I'm inheriting every single behavior of Python 3.11 to my application itself. And then I'm copying into an app directory, which means I'm defining, okay, what's going to be the running directory of my application. So I can define it right over there and then copy the requirements, like the requirements of txt file into the image and the install dependencies. For an example, if I have a specific commands to run to install the dependencies, like the requirements of which is defined in the requirements of txt, I can I can have a command run option here, copying all files and exposing the port. Really important, right? Because we know that when you start a Python Flask-based application or any sort of application, that will run on a specific defined port. It could be port number 5000, it could be port number 8000, 8080, 800, 80 or 443, right? There could be different types of port the application has to run. So now if I go to the starter.py file, you can see in the last line of code, it says my application has to run on port number 5000. So because of that, in my Docker file, I have mentioned that to expose port number 5000 to the outside world, right? So I'm exposing my port number 5000 to outside world as a configuration. So that's what I'm doing here, right? So then I'm defining, okay, what are the environment variables? And then finally, with this command, I can start my application just like a normal Python command to start this Flask application. So done. I have made the configuration. So if you guys wanted to write Docker files, don't worry. You guys could use some tool like Cloud Code, or even you guys could use, even the code generators. You guys could give instruction like, based on my application, write a Docker file. It's a single file generation. So you guys could use like AI code generator as well, like Cloud Code or Copilot or something like that. It's not a difficult process. So after we do this, what's next? We can do a local build and see whether this is actually working properly, right? So we can actually see, we can build this Docker container. So before that, let's start Docker and let's see whether that's actually working, right? All right, so now Docker is starting up. So let's wait for a couple of seconds until, okay, all right. So now, perfect. Let's run the build command. So my build command is basically Docker build dot, right? Docker build dot means I'm saying, okay, this is my correct directory, this is my current directory. So I can, with the dot command, I can define my current location. Let's say if I want to have a different name for my container, what I can do is I can use this parameter called -t. So with that, I can say, I can define a name for my container. I'll just say workshop API, something like this. Now you can see it's building my application, right? So you can see it's pulling the container artifacts, and right now it's building my Docker image. This is only for the local reference, right? This has nothing to do with what I'm going to do in a while on the cloud deployment. This is only for the local reference, just to see if the image is working, if the image is being built, and if it's properly being, properly being called. So it's only a local reference. So don't confuse this with what I'm going to do in a while. So let's see how it works. All right, so it's going to take a couple of seconds, somewhere around, let's say 60 seconds or maybe even more. So we'll have to wait for that. So once after this deployment is done, once after the build is successful, we can run it and see to understand how it works, to how it operates in our machine. So now it's almost done. Let's wait for a couple of more seconds as well. Okay, almost there. All right, so now you can see it's installing my dependencies step by step, right? So previously it downloaded the Python base image. Now it's installing my dependencies, which is Python Flask. Done. So now you can see the container was built. Now if I run this command called Docker images, you can see my image is here. It says workshop API latest, container name is here, and then container ID is there. So I can actually run this container now. So what I can do is there's a command called Docker run, and then you can define the name itself, and then it will run my application. So you can see, right? I didn't install any of the libraries in my application. It's separately, it's currently isolated, right? I don't even need to have Python installed in my application to run a Docker container, which is a Python-based Docker container, right? If you're running on a different OS even, you can do that, right? It doesn't require any sort of software to be installed in my machine. So now it's running. So let's try to access this on a browser and see what happens. It's a localhost address. permission denied, right? Why is that? So even if it's running, I didn't pass a parameter. So you have defined the port itself. So you can use this command called -p, and then you can define the host port and the container port. So container port is basically defined Docker image itself. You can see the container port is 5000 and host Docker container in a different port on my local machine. Yes, I can do that. So the first 5000 is called host port. Second 5000 is basically known as a container port, which is defined over here itself. So the port that you define in the Docker file, Docker run, host port and the container port. So I'll make a small change. I'll just say 5001, right? Let's say if I want to access the container which is running on Docker on port number 5001 on my machine, I'll just say 5001 and I'll try to run that basically. I'll just run this application and let's see what happens now. Okay, it's running, right? You can see the application is running on port number 5001. And even though I have the container port defined as 5000, it's running on port number 5001. It's properly working now. I can even access my documentations since I'm done with Python class older version. It doesn't have the documentation. So depends on your requirement. You can define the host port and the container port all together so that we could inference it locally before you deploy it somewhere. Right. Perfect. Now it's working, right? So you can see the images are here and the running containers are also here. So now I stop the container, so it's not visible over here. So everything is there. Now let's talk about the deployment. So let's go to Google Cloud and then we'll access a service called Cloud Run. Right. So we are going to use this service called Cloud Run to deploy our container onto the GCP platform. So now what we could do is we could see there's an option called connect repository. There are multiple ways of deploying containers. First option is called connect repository. We could choose this and we could pick one, right? So you can see the second option is called continuously deploy from a repository. And there's an option called setup cloud build. So we could set it up right here. Okay, my repo is given. So you can see the provider is called GitHub because it's in my GitHub profile. So let me stop this also. All right, it's taking a bit more time. So let's wait for a couple of seconds. Okay, it's coming. So now let's search for my repository. It's called Flask demo. So I'll just click on this option as well. Next. All right. So in the next step, we could actually, give the build configuration. Okay, how it should build your application and what sort of building configuration should be there. So I should define the location of my Docker file, right? So you can see my Docker file is there in the root directory itself, in the most parent directory itself. So I don't need to go into subpaths. I'll just say Docker file, and I can give my branch also. So I should be in my main branch. So even if I'm using a different branch, I can mention it over here and click on save. All right. So service name is defined, region is defined, right? I can choose it if I wanted, based on the requirement, and then authentication. If I want to allow public access, I'll just say allow public access without having to log in through a Google account, and scaling, right? So I think I already mentioned all about the auto scaling factor, right? How do you make sure the application would scale up for a larger traffic? So don't worry, we don't have to set up any sort of additional infrastructure on Cloud Run. We could just mention the minimum number of duplicates your application should have, and the maximum number of duplicates the application should scale up to. So the minimum number of duplicates and the max number of duplicates we can always define. So I can start with 1, and maybe for the max number of duplicates, I can say 5. So depend, for an example, if it if there's a heavy traffic that comes on, it will create 5 duplicates of my application, of my server, and then the traffic will be distributed. So that's the meaning of the 5 duplicates. And one more thing is that on Cloud Run, they have option called cold start, right? So I can say the minimum to 0. So 0 means it's a cold start, which means when there's no traffic at all, it won't cost you, right? Because usually these cloud providers are charging you on an hourly basis. So it's going to cost you some sort of dollars, some amount of dollars when you're spinning out the service and on any time. But if you want to keep the server shut down at a time there's no active users available, we can say the instance count is 0, right? So it's a cold start. What happens is the moment someone comes into your application, it will automatically start the application on the beginning itself. So we call it as a cold start option. So we can just say 0, but I'll go with 1 for this. All right, ingress as all. And for the container, it's going to build the container for us, but the container port has to be changed. So the port is 5000 now. Like I mentioned earlier, it's 5000. And you can define the resources also. So let's say you can set the memory, you can mention the CPU, right? And if you want a GPU, you can do that as well. If you require some sort of GPU operation, you can attach a GPU as well. And you can set up any sort of environment variables. If you have any, you can do that. And you can mount any sort of hardware, any sort of hard drives, any sort of storage, right? So those sort of things can be done. But the most important thing is defining the correct container port and the resources and the scaling strategy. Right, okay, let's click on create. Let's see what happens now. Okay, so we need to enable the billing, but I'll use a different project for this. My apologies. We'll switch to a different project and let's create the service right here. Deploy a container and choosing GitHub, set up cloud build, and then I'll choose the repository. All right, Flask demonstration, and then next. Let's wait for a couple of seconds to spin up this. All right, Docker file is there. So I already explained these things and save. Let's wait and see what happens next. All right, done. So service name is there. Region, we can choose whatever. I'll go fast because I already covered these things. So I'll skip these things and I'll straight away go to the part we have stopped. Okay, traffic, and then allow public access. Traffic is all. Container port is 5000. So yeah, you already covered these areas. And then resource, I'll make it 1 GB, 1 CPU, and there's no environment variable, so I'll skip that as well. So at the end, I can just create the Cloud Run instance. Let's see what's going on here. All right, so now you can see it's creating the instance. So you can see it says pending. If you click on refresh, you should be able to see the status of this. So you can see it says pending, and it's actually building our image right now, right? So in the background, in the Cloud Run service, it's building. So you can actually see the logs by clicking onto this. Let's see the logs, what sort of logs we have in the play. All right, so from here, you can actually see the build logs. So you can see it's pulling from the Python base image library and it's creating the container. And at the end of the day, and at the end of the process, it's pushing the container to this thing called GC, the Google Artifact Registry, which is known as the Container Registry of Google. So right now it's building the container. And once the process is done, it will push my container into Google Artifact Registry. Now that is also done. So let's wait and see what's happening next. All right, so now I think it's almost done. So let's refresh and see. Right, now it's almost active. After successful deployment is done, it will give you URLs so that URL can be made public. You can even link third-party domain names as well to Cloud Run. Let's see. All right, this is my URL. So I'll just copy it right here, and then let's try to access that. So now you can see my application is working, right? So let me share this link with you all as well so that you guys can see. Now it's working properly. It's publicly made available to public as well. You can see successful, and it didn't even took a long time to deploy. And also you guys could do observability. For an example, you all can see the CPU utilization, memory utilization, and every single parameter of the application under the metrics. You guys can see how much of RAM it's using, how much of CPU it's using, and the request latencies, right? So all those things can be seen under this section. So yeah, under this section, you guys can easily experience the latencies, things like that, if you want to monitor your application. And most importantly, you guys can see the application logs. There's a section called logs. So in the log section, you guys can see the application is running, right? So you can see the incoming requests I'm getting from you guys, right? All these application logs saying that, okay, this person has access. So all these logs are coming now that you guys are accessing the application itself. Right. So that was easy, right? I believe, can I see a raise of hands, those who found it easy? All right, cool. A lot of people. All right, so we'll move forward and I'll come back to the questions after this. Right, I spoke about the artifact registry. I spoke about the building process. Let's see what's left. Right. So we discussed about many things, right? We discussed about the compute engine. We discussed about the basics of DevOps, CI/CD pipelines, the compute engines, and things like that. And we discussed about the concept of containerization. And if you guys want to try out, if you guys are into AI side, there's a platform called Vertex AI, right? Google has their own AI engine, AI platform called Vertex AI, which is one of the greatest platforms that anyone could use to deploy an AI agent or any sort of run an AI model and deploy AI model on cloud platform. So they have now it's being rebranded as agent platform also. But if someone is seeing on an options to deploy AI agents and complex AI models, yes, Vertex AI or the agent platform is one of the perfect places that you guys could use. And they have notebooks, they have agent deployment operations, they have models, and they have many other options that you guys could use to deploy your models and agents on GC platform. So you all can try it out. And they have the latest models as well, right? You can see the Gemini 3 models are there, the Claude models are there. So you can actually inference your own Claude model as well. So they have even given access to Claude 4.6, 4.7, because Google has the partnership with Claude as well. So if you guys want to access their flagship models on a on hardware infrastructure, you guys could do that basically. So that sort of operations are possible with the agent platform of Google. So yeah, if you want to go through it, I have another video. This is one of the workshops done by me. So you guys could follow up with this as well. If you guys want more information, more additional information about agentic AI and Vertex AI, as well as the capabilities of this platform, feel free to go through it. Right. So we are at the end of the workshop, but we are coming to the most interesting part, I guess. I promised you all something in the beginning, right? The free 2000 USD of cloud credits. So I'll provide that to you all as well. Before that, let's talk about the other possibilities we have. We already spoke about the compute stuff, app engine, compute engine, and content engines, and storage. Google offers storage as well. For an example, they have something called cloud storage. They have something called cloud SQL, right? If you guys want to have a file storage system or some sort of a SQL kind of databases, yes, they have storage options. And then they have for big data, they have something called BigQuery, PubSub, Dataflow, and there are multiple solutions they have provided from Google itself. For machine learning, we already spoke about it with Vertex AI platform. They're giving you all access to their flagship models. Yes, these are the possibilities we have with GCP. Right. So anyway, before we come to the final segment, you guys could join us at our different, because we host a lot of events from GDG community, from university hackathons to workshops to flagship events like Google I/O to DevFest, all of these events. So if you guys want to stay in touch with our community, you all can actually join our community. I'll show you all QR code. So you guys could join our community. We empower developers from all around Sri Lanka. 5,000, helping 5,000 plus developers in our community. So you all can be part of that as well. So as part of the GDG program, they're offering you all 2,000 USD of free credits for product-based startups, right? This is not for service-based startups. I had clarified that this is mostly for product-based startups. They're offering you 2,000 of USD free credits for time span of one to 2 years, right? So you guys could use that. I'll provide you a link, QR code that you all can take a screenshot of that. But not only 2,000, if you qualify with the investor or accelerator program, you all can get some sort of extension up to 200,000 also. For an example, if you have investor or some sort of pre-seed round, yes, you all can actually qualify for credits up to 100,000 to 200,000. So those sort of benefits are there, especially for AI and Web3 startups. They're offering you this benefit. So you all can apply for that. And yeah, so now it's your chance, right? You guys could take a screenshot of this. Maybe at the end, I can share the slides as well. If you want to become a member of GDG, feel free to scan this QR code. We have an interesting event coming up on next 2 weeks, which is known as Build with AI. So if you want to stay updated with whatever events that are coming up, feel free to scan this QR code and join our community. I'll provide you a link of our WhatsApp community as well. So for frequent updates that you guys are getting, and for cloud credits, yes, this is your link. Take a screenshot and apply and let us know what you all think about that. Right, what's next? So like I mentioned, Google provides you $300 of free credits, but if you sign up with a campus email or something, you can extend that up to 400 as well. And then you all can try out this website called CodeLabs, which has almost all the Google learning materials, which is one of the greatest platforms that I can recommend to anyone to try out the Google products and solutions in a interactive way. And then we have, if you guys want to get access to free software like, IntelliJ's, things like that, there's something called GitHub Student Pack. You guys could use that as well. It's not something to do with Google, but it's something value added that you guys could try. And like I mentioned, the play with Docker option is also there. So yeah. And let me share the WhatsApp link, y'all, the WhatsApp group link as well, so that you guys could, join our WhatsApp community as well. In the meantime, I'll take up some questions that you guys have raised in the chat. So then we can wind it up, basically. All right, so we have a question. Is there a reason why Sri Lankan government hasn't tapped into this yet? The scalability is highly useful for our purposes, right? Of course, it's very useful. I actually can't make a comment on the development decisions they have taken. So there could be many reasons, but they should really consider about the scalability factor for sure. Because see, for an example, the same scenario I've taken, the examination results for O levels and A levels, they should really think of the scalability factor, right? When millions of people accessing. So even the same thing happened for the fuel pass, if you can remember during the COVID time, same thing happened. And even the recent days when the war came out, right? The same thing happened for the fuel pass as well. So I think they should really care about the scalability factors as well. Yes. Any other questions that I can address here? I have shared the link in the chat of our WhatsApp community so that you guys could join JDG Sri Lanka WhatsApp community as well. All right, so we have another question. Do you recommend Golang or Node.js or backend more? Right, tricky question once again. I would say if you're looking at higher concurrency rates and lower resource limits that utilizes less hardware, let's say less RAM, less CPU, I would say Golang would be the best option for concurrent kind of options, which for application that has higher concurrency, Golang would be the perfect option. Yes, and Node.js is actually really good if your application is very structured and if it's well formed. I would say if you're working with higher complexity data models and if you want to work with a lot of libraries, because Node.js supports almost like millions of libraries we know as of now, right? So I would say if you're looking at the extensiveness, Node.js could be a great choice. But when you're hiring Node.js developers, it's easy. But when you're hiring Golang developers, it's very less. So I would say if you have access to the resources, let's say if you have access to those libraries and human resources, yes, Golang could be a perfect choice because right now, even for cloud computing, even for writing Kubernetes-based operators, Golang is one of the best options you can recommend basically that is there. And if you want higher flexibility, Node.js would be the perfect option. Yes, I have already shared the slide deck that I mentioned earlier. All right, so any more questions that I can address? If there's no other questions, we can wind up for the day. We have all taken some around 8 to 9, I think 8 questions so far. All right, so that's all for the day, it seems. Feel free to reach out to me on LinkedIn if there's any further discussions on this sort of technologies. So yeah, I'm there on LinkedIn. So the slide deck will come on my on my personal website, which is sureshmichael.com. The slides will be available by tomorrow. So you guys could access that. It will be right on here. So yeah, I'll be uploading my slide deck on this website, my brand new website. So yeah, feel free to let me drop that link in the chat as well. Yes. All right. That's all for the day. Thank you. I'll hand over to the community. Thank you. Thank you, guys.
What a truly insightful and inspiring session that was. Thank you so much, Mr. Suresh, for sharing your knowledge, experience, and valuable industry insights with all of us today. I'm sure that everyone gained a much clearer understanding of how technologies help transform ideas into scalable and production-ready solutions. Ladies and gentlemen, as we come to the close of today's session, we would like to extend our heartfelt gratitude to Mr. Suresh Peiris for being with us and delivering such an engaging and informative session. Your passion for cloud technology and innovation truly inspired us today. As a token of our appreciation, we would like to present a small memento in recognition of your time and contribution to Beauty of Cloud 2.0. Thank you once again, sir. Before we conclude, we would like to take a moment to sincerely thank the organizations who supported and believed in this initiative, helping make Beauty of Cloud 2.0 a success. A special thank you to WSO2, the annual silver sponsor of the IEEE Student Branch, University of Sri Jayawardhanapura Computer Society, for your continued support and contribution. We also extend our appreciation to Ranmuthu Hardware, the official bronze partner of Beauty of Cloud 2.0 for being a valuable part of this journey. A heartfelt thank you to Pearl Bay, our official gift partner, for your generous support. And special thanks to HackSL, our official digital media partner, for helping us reach and connect with a wider audience. We would also like to express our sincere appreciation to ICTS Faculty of Technology for collaborating with us and supporting this initiative. Your contribution and partnership played an important role in making Beauty of Cloud 2.0 possible. And finally, to everyone who joined us today, thank you for being a part of Beauty of Cloud 2.0. Your enthusiasm, participation, and engagement are what truly made this session meaningful and memorable. We hope today's session inspired some new ideas, expanded your knowledge, and strengthened your passion for cloud computing, technology, and innovation. Thank you once again for your time and support. We look forward to seeing you at our future events as well. Have a wonderful evening, everyone.